Hi, and welcome to today's video. Thank you once again for joining me. Today we're going to talk about solving systems of equations, only this time we're going to talk about using substitution for solving our system of equations. So you might remember last we talked about solving systems of equations using graphing, and remember the solution, of course, was that point on the graph where the two lines crossed. And so now we're going to do that algebraically without having to graph our two equations. So first, let's start out with some steps. I thought it might be helpful to list out some steps that you could follow for solving using substitution. So the first thing we want to do when we're solving a system of equation using substitution is solve one of the equations for either variable. So if you have two variables, say x and y usually, solve one of the equations for one of those variables. Doesn't matter if it's x that you're solving for or if it's y that you're solving for. You just need to solve one of the equations for one of the variables. Sometimes you'll be given equations where one of the equations is already solved for one of the variables, so sometimes you can skip this step. The second step then is to substitute the expression that you found for the variable into the other equation. So let's say you solved it for y equals something. So you take what y is equal to, whatever that something is, and you put it in for y into the other equation. The next one is, next step, solve for the remaining variable. So if you solved for y up here and you plugged it in, you're going to have an equation in terms of just x. So you need to solve for that x, whatever that may be. And then next, substitute the number that you found for x, or if it was y, either way. But substitute the number you found into either of the original equations and solve for the other variable. Okay, and of course you can always check your answer at this point. Check your answer by substituting both numbers into one of the original equations. Usually if you used one of the equations to solve for the other variable, you would use the other equation to check your work. Okay, so let's take a look at an example of that. Example 1, solve each system of equations. So here we have a system of equations, y equals 2x plus 5, and 2x plus y equals 13. And by the way, these brackets are just telling us that this is a system of equations. So the first system is, or the first equation is already solved for y. So the first step, we can kind of skip that. It's already been done for us. So remember it said take that expression. So we're taking this expression 2x plus 5 and we're putting it in here into this other equation for y. So this becomes 2x plus y, which is 2x plus 5, equals 13. And now we have enough information we can solve for x. So combine like terms, 2x plus 2x is 4x, plus 5 equals 13. And now it's just a matter of solving for x from there. So subtract 5 from both sides. We get 4x equals 8. Divide both sides by 2, we get, by 4, and we get x equals 2. Okay, so now once we have that, what x is as a number, we can substitute it back into this other equation and solve for y. So when we do that, y equals 2 times 2, which I have right here, plus 5. So 2 times 2 is 4, plus 5 is 9. So our answer is x equals 2, y equals 9. So use the other equation to check your work now. So put 2 in here for x, 9 in here for y, make sure that it works. So 2 times 2 is 4, plus 9 is 13. So we have 13 equals 13. It does seem to check out. So the solution is the point, 2, 9. Okay, so maybe let's take a look at another example here. We have negative 7x minus 8y equals 6, and 2x plus y equals negative 12. Okay, so remember the first step is solve one of the equations for one of the variables. I usually like to choose one that maybe has the smaller numbers or that looks like it's going to be easier to work with. And notice this one just has y by itself. So we can very easily solve this particular equation for y by subtracting 2x from both sides. So we get y equals negative 2x minus 12. Okay, so remember the second step is now to take this expression and substitute it in here for y. So I have done that, negative 7x minus 8 times the quantity, and it's important to put this in parentheses because we do need to distribute this 8. So 8 times the quantity, negative 2x minus 12 equals 6. Okay, so now we need to solve for x. So first, distribute the negative 8. So negative 8 times negative 2 is plus 16x. And negative 8 times negative 12 is plus 96. So we end up with negative 7x plus 16x plus 96 equals 6. Subtract the 96 from both sides. We get 9x equals negative 90. Divide both sides by 9. So we get x equals negative 10. Okay, so now remember the next step, step 4, was to use that number and plug it into one of the equations and solve for the other variable. So if we go back to this one, we can substitute negative 10 in here for x. So I've done that right here. 2 times negative 10 plus y equals negative 12. And now we can solve for y. So 2 times negative 10 is negative 20, plus y equals negative 12. Add 20 to both sides, we get y equals 8. Okay, so we have negative 10 for x, 8 for y. Remember, we do always want to check our work. So substitute that back in. And I'm going to use this equation to substitute it back into. So negative 7 times negative 10 minus 8 times 8 equals 6. And negative 7 times negative 10 is 70, minus 8 times 8 is 64. So 70 minus 64 is actually 6. And so it does seem to work out. Okay, so remember those steps. Solve for a variable, substitute that expression in, solve that variable for whatever it is equal to that's left over, substitute that back in, solve for the other variable, and check your work. Okay, so another couple more examples here. Example 2, solve the system of equations using substitution again. And so we have this particular system. 4x plus 8y equals negative 6, and 6x plus 12y equals negative 9. So first thing we need to do is solve one of them for one of the equations, or one of the variables. So I'm going to take this one, the top one, and solve it for y. So subtract 4x from both sides. We get 8y equals negative 4x minus 6. Divide through by 8. And we get y equals negative 1/2 x minus 3/4. Okay, so remember the next step. We're going to substitute it back in to the other equation. So we have 6x plus 12, which comes right here, 6x plus 12, times whatever y is. And y was negative 1/2 x minus 3/4 equals negative 9. Okay, so 6x minus 6y when we distribute, 12 times negative 1/2 is negative 6x, and 12 times negative 3/4 is negative 9. So we have 6x minus 9 equals negative 9. So 6x minus 6x is 0, so we get negative 9 equals negative 9. So notice all the variables disappeared here. When that happens, we can kind of stop at step 3. We don't have to go any farther. But notice that is always true. So remember when we talked about dependent systems and inconsistent systems, since this is always a true statement, what is happening here is these are the equation of the same line. And so we have a dependent system. So we have an infinite number of solutions in this case. So to state what our solution set is, it is the set of all points such that, the set of all points x, y, such that y is equal to negative 1/2 x minus 3/4. And you might be wondering where I got that from. Well, I got that from right here because we put one of the equations into slope-intercept form, and that's what we need to do here, is just show all of our solutions are on this line. All the points that make up that line are the solutions. Okay, so moving on, next example. 2y minus x equals 4, and 1/2 x minus y equals 2. So again, solve one of the equations for one of the variables. So I'm going to solve this one for y. So go ahead and subtract 1/2 x from both sides. We get negative y equals negative 1/2 x plus 2. Divide through by negative 1, and we get y equals 1/2 x minus 2. So remember now, substitute that into the other equation. So 2 times y, so I took 2 times what y is, 1/2 x minus 2, minus x equals 4. And when we distribute here, 2 times 1/2 is 1, and 2 times negative 2 is negative 4. So x minus 4 minus x equals 4. Well, x minus x is 0, so we end up with negative 4 equals 4. Okay, well, we know negative 4 doesn't equal 4, so that's not a true statement. So in this case, what is happening is this is an inconsistent system. There are no solutions because this is not a true statement. That can't happen. So there are no solutions in this case. So again, it's an inconsistent system. So really, that's all I have for you today. Thank you once again for joining me, and I'll see you again soon.